In this section we're going to consider some other types of integrals, and these ones are going to be those that involve trigonometric expressions. Now we've already seen how our change of variable technique might be useful, but this time we're going to consider our trig identities. So let me just remind you of a few from our formula sheet. So there's a couple from our Pythagorean identities, and we've got a third one of those as well. Here's a couple of our sort of double angle identities, so involving sine of 2a and cos of 2a. So this time we're going to say, well, maybe if we've got an integral involving a trig expression, we can actually substitute it for a slightly easier trig expression and integrate that way. Now I do have to say right at the outset, there are so many variations of integrals that we could get with these that unfortunately they're not all that obvious, and there's not necessarily really obvious patterns to learn. So we've just got to do our best, and like lots of things with trig identities, there could well be more than one way of doing them. It's just that often one way might be a little bit more straightforward than another. Now let me start, before we go on and actually attempt one, let me particularly talk about these sort of identities down here. So cos 2a, note, can be written as an expression involving sine squared a, and also as an expression involving cos squared a. So from that, if we rearranged that last one there, and maybe I should use a because that's the form that that one's in. So if I said that cos 2a is equal to 1 minus 2 sine squared a, then with a little bit of rearrangement there, and you could sort of do the intermediate lines of working out, but I could say that sine squared a can be written as a half of 1 minus cos 2a, and likewise cos squared a, from that very last line, well, we could rearrange our identity to say that cos squared a can be written as a half of 1 plus cos 2a. So let's do an example straight away where we could use one of those. Let's go to the exercise 11F, and straight up in question 1, part A, we've got the integral of sine squared x dx. Now we can't use a change of variable technique here, because if we let u be equal to sine x, then we're going to get a derivative of cos x, and there's no cos x in that expression there. However, using what we've just talked about over here, and that is that sine squared x we could write as half of 1 minus, so let's write it as a half of 1 minus cos 2x dx. So now we've sort of simplified that from a second order trig expression to a first order trig expression. Let's take the half outside the integral and just say it's 1 minus cos 2x dx. So what's that going to be a half of? Well, the integral of 1 with respect to x is just x, and the integral of negative cos or minus cos 2x is going to be minus a half sine 2x plus c. So there's our integral there, and we don't really need to do any more than that with that. Alright, let's consider one more example in this video, and like I say, there's so many different possible examples, but this is one where we'll actually use both one of our trig identities and also a change of variable. So this is a fairly classic one, and let's do an odd power. So this is from the exercise. We've got an odd power of cos, so cos cubed x dx. So again, we can't use a change of variables straight away. However, if we write that as single power of cos times cos squared, so cos cubed is just cos x times cos squared x, and then we could write, using our Pythagorean identity, we can say, well, cos squared x is 1 minus sine squared x. So now we could use our change of variable by letting u be equal to sine x, and therefore du dx is cos x, and so it follows that dx we could express as du over cos x. So what's our integral? Cos x 1 minus sine squared x dx we can now write as integral of cos x times 1 minus u squared times du over cos x. That's going to cancel out our expressions involving x and leave us purely with an integral in terms of u. So the integral of 1 take u squared du, well, integral of 1 with respect to u is u, integral of u squared with respect to u is u cubed over 3 plus c, and subbing back in sine x for u, we would have sine x minus 1/3 sine cubed x plus c. So there we've sort of combined our two techniques together, but right at the start we couldn't have done that with a change of variable, so we needed to use a trig identity there.